All right, today I'm going to go over section 9.2, which is piecewise functions. What piecewise functions means is that you have a function that changes in between different inputs, different regions for x. So why this would be like if you're gonna, I don't know, if you're gonna make a new item, you're gonna make like you're gonna make purses, okay? You have to pay $5,000. No matter what, right up front, you're gonna pay $5,000, and then for the first, let's say 2,000 that you make, you're gonna pay $1,000 each. Okay, so it's gonna look something like this. You got to pay 5,000 right away, and then for the first 2,000, it goes up 1,000 each. Then after that, it's gonna go up at anything over 2,000 is gonna go up at a rate of, let's say, I don't know. It goes up half as quickly. So, okay, I'm going to go over section 9.2, which is piecewise functions. Piecewise functions, what they are is they're functions that change. They have different values of y, different rules for y based off of the inputs for x. So this is like if I'm talking about the cost per ounce of sodas and I look at the different things that I buy. So like the cost per ounce of sodas, if you're buying them in, if you just buy a 1 liter, it's like $1.25. So a 1 liter gets you like 20 ounces. And so you're paying, I don't know, you're paying like 7 cents an ounce, something like that. So if you're paying 7 cents an ounce for every ounce, it looks like this. But then if you bought them in 2 liters, you pay a lot less. You pay like 99 cents for a 2 liter, which is like, I don't know how many ounces are in a 2 liter, to be honest. Let's say 60. So you're paying a lot less per ounce for the 2 liter. So as you're going up in ounces, it's going to change. So now we're going to change the value that we would purchase. Once we get to here, you can buy a larger value. So you're going to go down to this, and this is how much you're paying per ounce. And then once you get up to a certain amount, you're going to probably buy a 6-pack. In a 6-pack, you're paying like 12 cents an ounce. So it's going to look like this. And then after a certain amount, you're going to jump up to 12 packs. And in a 12-pack, you're going to pay less per ounce, and it's going to look like this. So all I'm trying to get across on this, obviously this graph is not correct for what I'm talking about, but what I'm looking at is on this region right here of x, I have a different rule than in this region of x, and on this region of x, and on this region of x. So we have different rules based off of it. So what the function would look like is something like f of x equals, and then we write one of these in order to put all of the different rules in. So in the beginning, it was, let's say, I think I said it was like 14 cents an ounce. So 0.14 x plus, and you had an initial amount that you had to pay. The y-intercept was right here. So I'm going to say it's plus 0.13. But this rule only applies in between x is 0 and x is 4. So I'm going to say if 0 is less than or equal to x is less than or equal to 4. And then as soon as I get to 4, I start a new rule. The new rule is something like 0.12x, and it looks like it has a y-intercept that's below 0, so I'm going to put it as minus 0.13. And this rule is only if I go from 4 is less than or equal to x is less than or equal to 8. And then I have another rule. My rule is now 0.12 or 11x minus 0.75 if 8 is less than or equal to x is less than or equal to, it looks like it goes up 3.5, so 11.5. And then I have another rule, 0.11x minus 1.6 if 11.5 is less than or equal to x is less than or equal to 14. So this is what a piecewise function looks like in function notation, writing out the function, and this is what it looks like on a graph. There can be a lot of different ways to do it. For example, if you go out and you're gonna have a pizza party and you're gonna buy one pizza for up to 4 kids. Well, if you have the pizza party and no one shows up to your party, you still bought that one pizza. So you have a price that you have to pay, let's say it's $10 for the pizza from 0 kids all the way up to 4. As soon as you get 4 kids, so this is going to be open because it's not included. As soon as you get 4 kids, you decide that you're going to buy a second pizza. So we go up, now you're paying $20. At 4 kids, you're paying $20 and you're going to let 4 kids up to 8. But as soon as you get to 8, we're going to jump up and we're going to buy another pizza. We call this a step function. Step functions, they are a constant amount that changes based off of increments, but we would do the same thing for the piecewise function here. So we would still write out the rule with f of x equals, what was it, 2 if, oh sorry, I said that was $10. $10 if 0 is less than or equal to x is less than 4. As soon as it got to 4, it jumped up. And then it went to 20 if 4 is less than or equal to x is less than 8. And as soon as it got to 8, it jumped up. And then it became 30 if 8 is less than or equal to x is less than 12. So we're stepping on increments there. And that's what we're looking at. So what I'm going to want you guys to do today, if you're in wave 3, the wave 3 group, what you guys are going to be doing is you're actually going to be going from the function to the graph and from the graph to the function. Now going from the graph to the function is kind of what I've been showing you right now. Going from the function to the graph is a little bit tougher. So from the function rule, what I want you to do, when they're not constant amounts, it's a little bit tougher. So I'm going to show you what we got to do here. What I want you to do is I want you to put the starting amount and the ending amount. Then you need to think about it. What kind of function is it? So if it's something like this, -3 is less than or equal to x, less than 0, 2x plus 1, if 0 is less than or equal to x is less than 3, and 7 if 3 is less than or equal to x. So this one's going to continue on. So what we're going to do here is, for my x's, I'm going to put in the starting value into the equation. So the starting value here is -3, but I don't have an x in here. It's just telling me that the y value, or the function, equals 3 from -3 to 0. So on my graph, I'm going to go to -3, and I'm going to go to 3. That's where it starts, and it's included. And I'm going to go to 0, and that's not included. And then I connect the 2 points. I'm going to do the same thing with this one right here. So I'm going to plug in 0. 2 times 0 is 0, plus 1 is 1. So I'm going to start at 1, and it's included, so I'm going to fill it in. And then I'm going to plug in the last value. 2 times 3 is 6, plus 1 is 7. So I'm going to go 3, 7. And that one's not included. And then I'm going to connect those two. I know it's a linear equation, so I'm just going to connect it with a line. And then the last one from 3 on is just 7. So I'm going to go to 3 and go up to 7. And this one is going to be included. So that kind of fills in that point that was open. And that's how we're graphing these guys out. Okay? So you're just start using the starting amount and the ending amount. If it's a constant rate, just go to the beginning on the x and the end on the x and then make that constant rate.